In this course you will learn what is lockout and tagout, types of energy hazards, types of locking devices, where to place locks and tag, the steps for lockout tagout, and how to restore from lockout. At our company, only authorized and trained employees may place a lockout on any piece of equipment. Only company-provided locks and tags are to be used for our lockout tagout procedures. The person who will be doing the work on a piece of equipment must be the one who installs the locks and tags, and after the work has been completed, only they are allowed to remove the locks and tags. Lockout tagout is the procedure we use to make sure that any hazardous energy associated with machinery or equipment is controlled before anyone works on or adjusts equipment or tools. Hazardous energy is energy that can harm a person, such as electrical energy, mechanical energy, gravitational energy, hydraulic energy, chemical energy, and thermal energy. All these sources of hazardous energy must be controlled by locking and tagging before work or adjustments begin on any piece of equipment. Electricity, even at very low voltages, can be hazardous. Under the right conditions, a 30-volt circuit can carry enough current to cause severe injury or death. Qualified employees are trained to use special personal protective equipment, lock and tag electrical circuits, use barriers around work areas, use voltage detection instruments, properly ground electrical equipment, and use electrically insulated tools. There are two types of mechanical energy, kinetic and potential. Kinetic energy is energy of motion from moving machine parts. Potential energy is energy stored in machinery by weights and springs, pistons under pressure, or hydraulic pressure. Uncontrolled release of stored potential energy can cause injury or death. Gravitational energy is similar to potential energy. It is the energy released when an object falls and then lands on a lower surface. If the lower surface is you, injury can result. Examples are levers, press plates, or pistons that could move after the restraining energy, such as pressure, connecting rods, or springs, have been removed. Another type of stored energy is hydraulic energy, or pressurized fluids. Normally we think of fluids as being liquid. However, this can include compressed air or gases. Hydraulic energy is released when the pressure is no longer contained, such as by opening a valve or pipe connection. Chemicals have energy that can start fires, cause skin burns, or generate harmful gases or fumes. Before working, know how to release, drain, or vent chemicals safely. Thermal energy is the energy of heat. Hot equipment and fluids will burn you, while cold fluids and surfaces can cause injury also. Rapid release of compressed gases can freeze your skin. Controlling hazardous energy means disconnecting or blocking the energy from the source. An example would be opening an electrical breaker or shutting a fluid system valve. The place where the lock is applied is called the control device or energy isolation device. Each type of energy control device has a specific type of lockout mechanism or locking device. The purpose of a lockout is to prevent inadvertent operation of the control device so that the equipment cannot be started without removing the lock. Covers are used to lock valves. Electrical breakers use breaker clips, and piping systems use blanks to block flow. Cord and plug equipment should be locked out before repairs or adjustment. By placing a locked plug bucket on the plug end of the electric cord, you prevent anyone from restarting the equipment. Whatever type locking device you use, make sure that no one can remove the device without unlocking the lock. Pipes can be locked out by several means. Block and bleed means you shut isolation valves upstream and downstream and bleed off any fluids in the work area or between two valves to prevent valve leak by. You can also block the flow in a pipe by installing blank flanges. Pipes may also be disconnected as part of the lockout procedure. Some equipment and systems lockout will involve more than one lockout device. Be sure you know the systems and where all the energy isolating devices are located. Each authorized employee is issued their own locks, keys, and tags by the company. Locks and tags must be traceable to the person who placed the lockout on the controls or energy isolating device, so don't let anyone use your lockout equipment and never use another employee's locks or tags. Duplicate keys to your locks are not allowed. Only you should have the keys. Be sure to use only company-provided locks and tags. More locks, tags, or locking devices are available either from your supervisor or from a Lockout Tagout center. If you don't have what you need for a full lockout, tagout, tell your supervisor. The first step in lockout is knowing the equipment hazards, system hazards, isolation points, and lockout procedure. Working on unfamiliar machinery is a hazard. The 6 steps in the lockout procedure are preparing for shutdown, shutting down the equipment, isolating all energy sources, placing the locks and tags, releasing stored energy, and verifying equipment isolation. Preparing for shutdown includes understanding the equipment hazards and notifying other workers of the equipment shutdown. The person who locks and tags equipment is called the authorized employee. Those who work in the area of the equipment you are locking out are the affected employees. Shutting down the equipment is the next step. Just use the normal shutdown procedure. The next step is to isolate all energy sources by shutting down control and isolation valves, opening breakers and disconnects, and blocking and bleeding all fluid lines. Step 4 involves placing your locks and tags on all necessary breakers, controllers and disconnects, valves, blank flanges, and pipe plugs that are used to isolate the equipment from external energy sources. The 5th step in the lockout procedure is to release internal or stored energy by discharging capacitors, blocking or releasing springs, blocking elevated parts, allowing rotating flywheels to stop, relieving system pressures, draining fluids, venting gases, and allowing the system to cool. The final step is to verify equipment is locked out. This step includes checking that all other workers are clear, checking that the locking devices are securely placed, rechecking the isolation, and then attempting normal startup. If the controls did not function, the lockout was correct. After completing step 6, remember to return all controls to the off or neutral position. If several people will be working on the same system or equipment, a group lockout must be used. In this procedure, one person conducts the lockout, and all other workers verify that the isolation is correct for the work they will be doing. The keys that are used for the group lockout are placed in a locked box. All workers then lock the lid of the box. This prevents anyone having access to the locked out keys until each worker is ready to have all locks removed from the system or equipment. Restoring equipment to operational condition after being locked out involves inspecting the area and equipment for hazards, ensuring all machine guards are in place, making sure all tools are away from equipment, informing affected employees of startup, restoring the system connections, removing the locks and tags, and restoring the equipment to normal operating condition. After completing these steps, you or the equipment operator may conduct a normal startup. If a piece of equipment already has a lock and tag, do you have to place your own locks and tags? Yes, each person working on the equipment must place their own locks and tags to ensure their safety. Our Lockout Tagout program is designed to protect you. Please use proper Lockout Tagout procedures every time. OSHA requires that corrective action be taken for those who do not follow the lockout tagout procedure.